Hi everyone, I'm Dr. Ma from First Affiliated Hospital of Santo University Medical College. Welcome to this session of clinical histology. Today we will talk about the cerebellum. Here are the learning objectives for you. At the end of this session, you should be able to outline the function of cerebellum, describe the layers of cerebellar cortex, summarize the function of Purkinje cells, explain the symptoms of cerebellar ataxia. Let's start off with a case. Mr. Simons, a 30-year-old man, presented to the clinic with complaints of difficulty walking in a straight line and swaying while walking in narrow passages for 5 years. He had a slow progression of symptoms. On examination, his muscle tone was normal, but coordination was impaired by severe ataxia. His mother and maternal uncle also had problems with gait, which were progressive and began during adulthood. MRI of the brain revealed cerebellar folia atrophy, and the patient was diagnosed as having cerebellar ataxia. The cerebellum sits in the back of the brain posterior to the brainstem. If you take the sections of cerebellum, we can see white matter and gray matter, and some gray areas that are basically the nuclei in the cerebellum. Neurons send their axons carrying input from the spinal cord, the brain, and the internal ear through the brainstem into the cerebellum. Once there, the cerebellum uses this information to coordinate and plan movement as well as maintain balance. Here is the microscopic section of cerebellum. Under low magnification, we can see the surface depressions of fissures shown by arrows separating the folia. The cerebellum consists of an outer convoluted cortex containing neurons, and a central core of white matter containing ascending and descending fibers. One of the characteristic features of the cerebellum is the uniform thickness of the cortex, irrespective of where we take the section. Let's have a closer look into the cortex of the cerebellum. There are 3 layers in the cerebellar cortex. From outside inward, we have the molecular layer, the Purkinje cell layer, and the granular cell layer. These 3 layers are named according to the type of neurons. Let's begin with the molecular layer, which is the outermost layer of the cerebellum. We can see it is the pale staining superficial layer, which mainly consists of neural processes with very few cells. The neural processes found in this level include dendrites of the Purkinje cells, parallel fibers, which arise from the axons of the granular cells, and the climbing fibers. It also has cell bodies and processes of 2 types of interneuron. The stellate cells are found close to the surface of the cerebellum, and the basket cells are located in the deeper part of the molecular layer. These cells are involved in the feed-forward inhibition of Purkinje cells. The middle layer is the Purkinje cells layer. It has a single layer of large pear-shaped Purkinje cells. Purkinje cell is one of the most beautiful neurons that you will ever want to see under the microscope. It has a very large cell body that gives rise to these incredibly remarkable branching patterns of dendrites. While most neurons in the brain grow dendrites in all different directions, the Purkinje cells develop theirs in a flat plane. Purkinje cell is the principal integrator of inputs that are coming into the cerebellar cortex. Dendrites of the Purkinje cells are present in the molecular layers, as we said before. The proximal dendrite branches of Purkinje cells are smooth and they synapse with climbing fibers, while the distal smaller dendrite branches have numerous spines on their surface, which synapse with parallel fibers. Dendrites of Purkinje cell receive massive input from these fibers. then send information out through axons. Purkinje cells are the only cells transmitting output signals from cerebellar cortex to its deep nuclei. The innermost layer of cerebellar cortex is the granular cell layer. As we can see here, there are numerous densely packed basophilic nuclei in this layer. These are the soma of granular cells that accounts for the majority cells of the cerebellum. The unmyelinated axons of granular cell ascends to the molecular layer. Then it bifurcates into two branches that runs parallel to the surface of cerebellar cortex, and so are known as parallel fibers. Purkinje cell receives lots of inputs from the axons of these tiny cells. In summary, the cerebellum coordinates our body movements. The cerebellar cortex receives information from most parts of the body and from many other regions of the brain. It has three layers: the molecular layer, Purkinje cell layer, and the granular cell layers. Purkinje cells integrate information and send signal out to the deep cerebellar nuclei, enabling accurate and well-coordinated movement. In our case of Mr. Simons, the atrophy of his cerebellar cortex leads to clumsy, poorly coordinated movements. Although his muscle tone was normal, the ataxia caused him the loss of skillful movements. Thank you, and see you next time.